fjord in Greenland. The risk of these Arctic landslides is increasing because of climate change, according to scientists, as Victoria Gill reports.
One of the strongest earthquakes ever recorded struck off the Russian east coast a few hours ago.
Quite enormous and damaging, but the coastline itself is very sparsely populated.
But in one fjord in the east of Greenland, a seismic event has transformed the landscape here forever.
The wave began with a whisper, though in Greenland that whisper was made of stone and ice. On September 16th, 2023, in the remote Dixon Fjord of eastern Greenland, a towering section of mountain gave way. Glacial melt had been gnawing at its base for years, quietly undermining the giant's stability until gravity did the rest. In an instant, 25 million cubic yards of rock and ice, enough to fill 10,000 Olympic swimming pools, tore free and plunged into the icy fjord below. The impact unleashed a 650-foot mega tsunami, one of the highest waves recorded in modern history, dwarfing skyscrapers and rippling outward with a violence that shook not just the fjord, not just Greenland, but the entire planet. At first, the disaster seemed to be just that, another catastrophic landslide made worse by a rapidly warming Arctic. But then came something baffling, something that left seismologists across the globe scratching their heads. Instruments from Alaska to Australia began recording a strange vibration. It wasn't the jagged spikes of an earthquake, which usually fade within minutes, but a steady, monotonous hum, and it didn't stop. For 9 straight days, Earth itself seemed to throb with an inexplicable pulse. Some scientists assumed their equipment had malfunctions. Others thought perhaps there had been a series of smaller, undetected quakes. But as days stretched into weeks, the mystery only deepened. What had Greenland unleashed? The answer would take a global collaboration of more than 70 scientists from 15 countries, armed with supercomputers, satellite images, and ground-level observations. What they discovered was that the massive wave had become trapped inside the winding walls of Dixon Fjord. Instead of dissipating, the water began to slosh rhythmically back and forth every 90 seconds, like a bathtub filled too high. This oscillation, called a seiche, created a resonance so powerful it transmitted vibrations into the Earth's crust. And unlike the fleeting violence of a quake, the sloshing endured for days, long enough to send seismic ripples racing from Greenland to Antarctica in less than an hour. The discovery stunned researchers. Seiches are not unheard of. They've been observed in lakes and harbors, typically lasting minutes or hours, but no one had ever witnessed one endure for 9 days. Christian Svenevig, a geologist with the Geological Survey of Denmark and Greenland, compared it to finding a new color in a rainbow, a natural phenomenon behaving in a way previously thought impossible. One scientist even tried to recreate the effect in his own bathtub, but the water settled in seconds. What happened in Dixon Fjord was on a scale beyond imagination, a literal reshaping of the Earth's heartbeat triggered by climate change. The human toll of this event was mercifully light. No lives were lost, largely because the fjord is remote and sparsely populated. Still, the mega tsunami erased centuries-old cultural heritage sites, damaged a research station on Ella Island to the tune of $200,000, and shook an abandoned military base. But scientists shuddered to think what might have happened had a cruise ship been in the fjord at the time. Dixon Fjord sits along a route increasingly popular with Arctic tourists. A 650-foot wave crashing into such a vessel would have left no survivors. This catastrophe is more than an isolated freak accident. It is, as many researchers now argue, a warning of things to come. The Arctic has warmed 4 times faster than the global average over the last few decades. Glaciers that have been frozen in place for thousands of years are retreating, thinning, and undermining the stability of the mountains they cling to. Permafrost that once acted as a kind of natural cement is thawing, loosening rock faces that had long been stable. As Svenevig put it, new areas of the Arctic are coming online for disasters of this type. Places that geologists once considered immune to such hazards are now potential flashpoints for mega tsunamis, and Greenland is not alone. Similar landscapes exist in Alaska, Western Canada, and Norway, where steep fjords and retreating glaciers make for a dangerous combination. In 2017, a tsunami in northwest Greenland, much smaller than the 2023 event, killed 4 people and destroyed homes. In the coming decades, as warming accelerates, the frequency and intensity of such landslide-triggered tsunamis could rise sharply. Each collapsing slope becomes a loaded gun pointed at nearby communities, tourist ships, and even global coastlines. The Greenland mega tsunami also demonstrated how advanced technology is transforming disaster science. Traditional seismographs provided the first hints of the event, but it was the new Surface Water and Ocean Topography (SWOT) satellite launched in 2022 that offered unprecedented insight. With the ability to map swaths of ocean 30 miles wide at resolutions of just 8 feet, SWOT allowed researchers to visualize exactly how the waves bounced within the fjord. Instead of grainy snapshots, they now had high-definition motion pictures of catastrophe in progress. Thomas Monahan of Oxford University hailed it as a glimpse of the future. Earth observation satellites that can turn remote, hostile places into open books, letting us watch hazards unfold in real time. But the data also painted a grim picture of vulnerability. Imagine a cruise liner coasting peacefully through a fjord as cliffs tower above. Now imagine 25 million cubic yards of mountain collapsing with no warning, unleashing a wall of water higher than the Statue of Liberty. That is not a scene from disaster fiction. It is precisely what Greenland narrowly escaped in 2023. The event underscored the urgent need for early warning systems, combining seismic sensors, satellite feeds, and AI simulations to detect when a slope is becoming dangerously unstable. In an era when Arctic tourism is booming and shipping lanes are opening through melting ice, the risks are no longer academic. Scientists like Paula Snook of the Western Norway University of Applied Sciences stress that what's happening is not just natural variability, but human-driven transformation. We are thawing ground which has been frozen for thousands of years, she warned, noting that each thaw destabilizes more rock faces. Rock avalanches are becoming more common in both Arctic and alpine regions, and with them comes the increasing likelihood of chain reactions, landslides that trigger tsunamis that trigger global seismic signatures. These cascading hazards, as researchers call them, are reshaping our relationship with the planet. The Greenland tsunami reminds us that climate change is not only about rising temperatures or sea levels creeping higher over decades. It is also about sudden, violent shocks. A single landslide in a remote fjord can send vibrations across continents, disrupting seismographs in Antarctica and satellites orbiting hundreds of miles above Earth. The Arctic is no longer a distant frozen wilderness immune to human influence. It is a dynamic, unstable system responding to our emissions in unpredictable and sometimes terrifying ways. When historians look back at the early 21st century, the Dixon Fjord mega tsunami may stand as one of those symbolic moments when the Earth sent a warning loud enough, literally planet-wide, for us to hear. For 9 days, the planet itself hummed with the aftershocks of our warming climate. The question is whether we will listen, because if we do not, then Greenland's mega tsunami will not be remembered as a once-in-a-lifetime freak event, but as the opening note in a chorus of disasters yet to come.